Okay, so for a slight change of pace, for at least this video, maybe a few more, I'm going to take some student code. I'm not going to say who the student is, though you may recognize your own code, or you may recognize something you've looked at over a friend's shoulder. I'm not picking on this code. I'm just picking it out because it has something that allows me to demonstrate something. So obviously, if this is your code, I'm going to give you some ideas about how to improve it. I'm going to try and not give away too much. But the real important thing is that you understand how to do some of these things. So this code is a Connect 4 game. And I think I have the page. It looks like this. Looks like an 8x8 Connect 4 game, which is a little different than normal Connect 4, but that's fine. And it's got some of the usual stuff, obviously adapted from the tic-tac-toe. In particular, right now, it doesn't have the dropping mechanic of normal Connect 4, so it's more like a 4-in-a-row tic-tac-toe game. So that's fine. That's a game one could play. So like in theory, and it says win down here. So what I want to look at is the win condition on this sort of 4-in-a-row game. So we'll start with that. So we're not going to worry about the dropping. And the thing that stands out to me about this code is that most of this code is in fact the isWinner function. And just because I can't help myself, the very first thing I'm going to do is I'm going to hit rename symbol and just fix the capitalization of that. Typically when we have two words run together or two or more, we capitalize the starting letter of each word except the first. So isWinner, so now isWinner is a function, and the idea here is it is called with a given row and column where the move was just made and is trying to determine if there's a winner starting or involving that move. So this, unlike tic-tac-toe, we're not going to brute force look at every single 4-in-a-row combination on the board because it's a lot more. It's actually, that would also work, but this is kind of how I've suggested to a lot of you to do it who are working on Connect 4. So that's what this code is trying to do, though, as I say, the isWinner goes from line 41 to line 125. So that's like 80 lines of code to check this one thing. So looking at this code, the basic strategy seems to be, there's a lot of loops here. Each loop is going from 1 to 4. So that's going to run 3 times. And it's comparing the row and column that were passed in 4. 4 is the name of our board. I'm going to just change that name too. I'm going to change that to marks just so we can be clear what we're talking about. So we're talking about looking at the marks at the given row and column and then comparing it to some related marks. In this first loop, it's going in the same row and the column 1 to the right, 1 to the right, adding 1. So the columns, as the column index goes up, we go to the right. And so basically, we're counting the number of cells to the right of the latest move to see are they the same, which makes sense because we're trying to see are there 4 in a row. So if we look to the right and we see some cells that are the same, and then maybe this next loop looks to the left, subtracting I, it's going to count. And if we see 4 in a row, including the one that just got played, then 4 in total, looking to the right and to the left, then that means the piece that was just played is part of at least 4 in a row. So that's all very reasonable, and that's this count up here. I'll just make some white space so we can see it. And we declare count with let because the whole point is we're going to change it. So it starts out at 1 for the piece that was just played. And then, and you might wonder what this is about, col plus I less than 8. So that's making sure that we don't go off the edge of the board. In this case, the columns don't really matter because if we go off the edge of the board, JavaScript is sloppy and we'll just get undefined, and undefined won't be equal to the mark in the current position. but it's a good practice to be aware when you're potentially going out of the bounds of the array. So like the problem here would be if the column we had just played in was, say, like the very last column, then adding even 1 to that would take us outside of the bounds of the board. So like if we had played down here and we looked to the right, we'd be off the edge of the board, and that doesn't make any sense. So the place where that really begins to matter is when we are changing the row, because if we go off the board like too far and get an undefined row and then try to index into that undefined value to get a column, then we'll crash and this whole function will stop running and the rest of the code won't happen and there'll be all kinds of bugs. So in general, we want to be careful about the bounds checking. Don't only use indices that we know are going to be in bounds. So that's what this check is about. And they're not applied consistently throughout this code. So that's one of the things we're going to clean up. Okay, so like I said, the main thing I notice here is just this thing is so long, and it's basically the same thing over and over again. It also has a little bit of an issue because the idea of 4 in a row is that you look in a line. So this loop is looking to the right and this loop is looking to the left. And if after those two, like we've looked to the right and we've looked to the left, we've seen 4 total of the same color, then that's 4 in a row. But if the count is, say we see just like 1 to the right, so we increase our count is now 2, and there's nothing to the left, then we come to these next loops and we start looking further down and further up, and then these loops down here are doing diagonals. We're looking in like all the directions and counting in all the different ways, and so I think we can see this like if I play here and here, and you can't, it's kind of small down here, but at the bottom here it says click to start because we haven't won yet, and then red is going to play here, and blue there, and red's going to play here. Still says click to start, blue's going to play here, and now I think, oh, I was wrong. Oh wait, well, okay, so there was maybe 2 bugs. So why did it say 1, 2, 3? Oh yeah, 4, right, so it looked, I just played in this blue square, and it looked in all the directions. So it saw 1 up there. So it started with 1 here, 2, and then it looked over here and it found 3, and looked down here and it found 4. So it's not really finding 4 in a row, it's finding 4 neighbors of the same color. Oh, and that's why this red one didn't work, because that only had 3 neighbors. But well, anyway, it already says win. Okay, so we got a couple issues here. So the main move is always the move. Like this this function is too long, and as a consequence, we're sort of lost in a maze of all these different loops. So what I want to do, and we have this problem that I just noticed, which is like we're not really checking 4 in a row. So what I want to do is I'm going to take these 2 loops, and I'm going to copy that count, and I'm going to come down here, I guess, at the bottom, and check row call. I'm going to paste that code, and so now I have one function that looks to the right, increments the count, and then looks to the left and increments the count. And then at the bottom, we can just return if the count is greater than or equal to 4. So this function is checking, starting from the current row and column, if we are now part of a 4 in a row, where the row is the same, and the columns go to the right and to the left. And the other thing that this is not doing, this is checking that we don't go out of bounds. It's in fact, well, I guess, and the column can go out of bounds over here because it can be negative, So we could fix that with a similar if col minus I greater or equal to 0, right? That's really the condition that we care about. Let me hit reformat on that. Oh, sorry, col is spelled with 2 L's here. And I wrote this as, like, this is the expression that we're going to use as an index. So I just use that same expression and check that it is in bounds. And since it's going down, the thing we have to check is it doesn't go below 0. So this is being very careful, and we're just not accessing any elements that are outside of the array. Like I said, in JavaScript, that doesn't really matter for the column index because we'll just get undefined. But it's maybe good practice. We can, I guess that's fine. And I don't know if we've all learned about break. I should have mentioned that before, but I think I probably told this student. So this is one way to write a loop where as soon as we see a cell that is not the same as our starting cell, then obviously we don't want to count anymore. And so we can break out of the loop. In fact, in this code, it doesn't really matter. It's slightly more efficient because, like, we stop as soon as we see a mark that's a different color or is empty. But maybe just to make less, we're more about clarity and less about efficiency, we could take that break out. And so now we're gonna look 3 times, and we're gonna stop if we go off the edge of the board, and then we're just gonna count. Oh no, actually, I'm sorry. I take that back. That logic is needed because the problem is that, say we've just played a red piece, and then we can show it on the board. Like, we play a red piece, and then let's say about a red and a blue, and then I play a red over here, and then a blue, and now I'm going to play a red right here. Well, when we look to the right, we're going to look one to the right and see a red, and then if we look again and we see a blue, it's not enough to just not count it. We have to actually stop, because otherwise we'll go one more and see, oh, there's 2 reds to our right, but it only counts if they're not interrupted by this blue one. So as soon as we see this blue, we need to stop. So that's actually what this break is for. So that gets us out of the loop. It's a way to sort of break out of the loop without returning from the function entirely, because we don't want to. We want to go on and do the next loop looking to the left. So this is pretty fine. Now looking at this, I see that I'm doing the same loop. This is looking to the right. This is looking to the left. Actually, I kind of need both. Okay, so that's fine. So let's just leave it like that. So now this function correctly does 1 row. And so that means that we can go up to where I copied this from, and actually what I'm going to do, I'm going to make a new isWinner. No, I'm not. Okay. So I'm going to come up here where I copied this code from. So that was these 2 loops. So I don't need those here anymore. And so I can say if check row call return true. All right, so if this function returns true, that means we found a winner. So there's a winner, and so we're just done. We can return true right away. So now I want to do the same maneuver. These 2 loops are, the row is changing and the column is staying the same. So that looks like we're checking for a column winner. So I'm going to do check column row call, paste that in. I need to add my count. All right, so each one of these functions has its own count. Always starts at 1 to account for the first piece. And then we do the same loop. And now this is where it's really important to check that we stay in bounds. So this, we're using row plus I to index into marks. And if that ever goes out of bounds, then we will get undefined and then try to use that as an array, and we'll get an error. So we only want to do this if row plus I is still inbound. Since it's going up, we check that it's less than 8. So that looks fine. Then we come down here. Well, this one is row minus I. So the problem is not that it's going to get too big. The problem is going to get too small. So we want to use the same expression that we're using in the index, row minus I, and we want to check that it's greater than or equal to 0. And if it is, then we check that the marks are the same and count them and so forth. And then as before, we return count greater than or equal to 4. Also notice that I'm just returning the value of this Boolean expression. I don't need to write, as the actual isWinner did, if count greater than or equal to 4, return true, else return false. Count greater than or equal to 4 is already a Boolean value. It's already true or false. And so this is just saying, if this thing is true, return true, and if it's false, return false. So I can just write that like this. Okay, so it looks like we actually fixed a little bug in the check column code. So that's good news. When we replace the code we just copied, check column, row call. Okay, so now you can kind of see how this is going. We're just breaking out the 3 different ways you can win: a row, column, or diagonal. And now, then I think we're going to see something else, and it'll be easier to see. That's kind of the whole point of this exercise. So I'm going to copy this code, do the same thing down here, cat const, and I assume this is checking a diagonal, row call, paste the code, and similar deal, loop from 4. This is checking almost the 2 things. So we have the same problem as we did in the column code, where the bounds check is not using the same expression as the actual index checks. So we want to fix that first. So this should be row minus I, and if we're going down, we care that it stays greater than or equal to 0. And then this one is right. The column is going up, and we want to check that it stays less than 8. And if those are both true, then we can perfectly safely check these marks, count them, break. Now for the second one, row plus I, that's the right one, but column minus I should be greater than or equal to 0. And then we can check, we can count, and we can return count greater than or equal to 4. So that's fine. And let's just think about what it's doing. So when the row number is going down, that's like moving up the board, because these rows are numbered from 0, 1, 2, 3, 4, 5, 6, 7. So let's say we're on row 7, and row minus 1 is 6, 5, 4. So minus on the row dimension is moving up, and adding on the column dimension is moving to the right. This is 0, 1, 2, 3, and obviously vice versa. So this code, the first loop is the row is moving up and the column is moving to the right. So we're moving diagonally up in this direction. And then the next one is going hopefully in the opposite direction, which it is. It's going, starting from some row, the row index increases, so that's going down, and the column is decreasing, it's going to the left. So that makes sense if we just put the blue one over here, and then red goes up here, so we're going to look up to the right and see, okay, there's one up to my right, and there's none down to my left, and then blue goes here, and now red's going to go there, and there's nothing on either side, and then blue's going to go here. And now this time when red goes, it actually detects the win because it sees 2 up and to the right, 1 down and to the left, plus the 1 that we just played, and that's 4. However, I don't think this is going to handle the case of a diagonal going, oh, wait, what? Okay, I'm surprised by that. How did that work? Oh, were there more? What happened? Actually, I'm very surprised by that because, oh, wait, have I not saved this at all? Never mind. Wait, is it that dimension that didn't work? All right, now I'm very confused. Let's just see what's going on here. Okay, that works. Column. That works. That does not. Oops. Sorry. Oh, well, okay, so that makes sense because I'm not actually, I didn't call my new check diagonal function. In the, where I deleted the code, if check diagonal row call return true. Okay. So now I have my check diagonal, and my argument is that this should only work for diagonals that are going from up and to the right. So let's check that. Going up and to the right. Detects the wind. Great. Going down and to the left. It does not. Okay. So I don't know what we saw before, but I'm a little bit confused. Okay, a little bit confused here. Okay, so this code is no longer necessary. But so the issue here, so now we can, like, this code is a lot simpler, right? It's like 5 lines long. Take out this console. Okay, but the diagonal, there's 2 kinds of diagonals. So let's just call this diagonal 1 and rename that diagonal 1. And now let's make a copy of this one. And so you might argue, hey, Mr. Seibel, you're actually making even more code, right? You were complaining that the isWinner was like 80 lines, and now there's like even more than that because there's like all these extra functions. But first of all, well, we fixed a couple bugs. And second of all, in a second, I think we're going to see how we can combine some of these functions. So check diagonal 2 is the one that we're going to try and check diagonals that go down and to the right. And so thinking of it that way, when going to the right is when we increase the column, and going down needs to increase the row. And so that means we need to fix our bounds check. I less than 8, and the column's bounds check stays the same. And then we got to obviously flip. We want to go up and to the left, which is the same as down and to the right. And that means that this bounds check goes there. And that diagonal 2 should now catch the down and to the left, so we can copy that. And then as a final, if none of these, we don't find a win in any of the 4 directions, row, column, or either diagonal, then we return false. Save that. Okay, so now let's check our downward right diagonal, and we see a win down here. And make sure that we didn't break anything. We'll check the upward But as you can see now, it's very unlikely that we broke anything because I didn't change the other check diagonal function. I didn't change where it gets called. And so it's easy to have a lot of confidence that like adding this line did not break this line, and that adding this function down here did not break this function because they're completely alone. All right, I didn't touch this at all. I could have collapsed that while I worked on this one. Okay, so now isWinner is a lot better, but we do still have kind of the maze of these 4 functions, row, column, diagonal 1, and diagonal 2, that are all kind of the same. And it would be nice if we could make them less the same. So to do that, I want to look at them and see, well, what's the difference? Like they all start with the count, and they all have 2 loops, and they all check the current value against some other value, and really and they have to check the bounds in a particular way based on sort of which direction we're going. But really, that's all determined by like, what are we changing? Are we changing the row or the column or both? And what direction are we changing it? So let's see if we can make a copy. So this is a new maneuver. So we have these 4 functions that we think are very similar. And so I'm going to copy one of them, and I'm going to rename it to something generic like check line. And I'm going to take all of the parts. I'm going to just start here by like put a little comment on any line that has something that's going to be like that differs, right? So the bounds check differs, the index we check differs, but the rest, this is the same between all of the functions. And then the bounds check and the index check, and everything else is the same. So that means if we can find a way to express that difference, maybe in terms of some arguments, we could write one function that does the functionality of all 4 of these. So for instance, let's look at what the actual difference is. So the main difference is this, plus I minus I. Or sorry, that's here. Plus I in check row, and it's unchanged in check column, but the row changes and it's unchanged here. So what if in check line, I add a variable row change and a variable column change? I guess I'll use 2L since match this. So these values are going to be either all these changes are either like I is really right, some variable 1, 2, 3, and it's always plus I or minus I. So if these values were 1 or -1, we could multiply I by that and get the right value. So here we're going to say row plus row change times I. So maybe even better, row direction, right? So the direction is either plus or minus. And likewise, I'm going to rename this one call direction, because the change suggests it's like the actual value, but this is going to be row plus row direction times I, and column plus call direction times I. And so that takes care of this one. And then we're going to do the same thing, except we want to flip the sign. So if row direction was positive, actually, let's look at column direction, because that's where we have check row. So when column direction is +1, this will go column plus 1 times 1, 1 times 2, 1 times 3, 1, 2, 3. And if column direction, but down here we want to subtract, and so I'm going to do minus call direction times I. So that will give us -1, -2, -3, just like this value in check row does. And then I just have to add the same row direction here. And so now, oh, and then so that takes care of this difference. And now the only thing that's left are these bounds checks. And so I'm going to do a quick little thing here. I'm going to write another function. So you're going to start to get used to this. Whenever I'm at an impasse, I just write a function. I'm going to write a function in bounds that takes an R and a C and is going to return true if they are both in bounds. And that's pretty easy. We return 0 is less than or equal to R, and R is less than 8, and 0 is less than or equal to C, and C is less than 8. So that's checking a row and a column and making sure they're all in bounds. And that's because this is an 8x8 board. Now, I guess I can, while I'm here, I'll make this even better. Marks, so the row has to be in bounds with the less than the length of the marks, and the column has to be in bounds with the length of the row that we're checking. So we've checked that the row's in bounds. Now we can get the row and check that it's length. Now in this case, these will still be 8 and 8, but maybe later if we change this to a traditional 6-row, 7-column Connect 4 board, this function will still work. So that's why it's good to not have hard-coded values that depend on other things if you can get it directly. Okay, so now I've got the in bounds function. So in my check line function here, I'm going to convert my bounds check to be in bounds, and then this is a little long, but same expression. Actually, no. Since I want to use this same expression twice, and it's a little bit long and complicated, I'm just going to make a variable other r, as in other row. So we'll even call it other row. And I'm going to do the same thing for other call and copy this expression. And so I can replace that with other call, and I can replace this one with other row, and then I can check in bounds other row, other call. And that gets rid of this difference, because this will now work for any check both bounds, which is a little excessive because one of them is probably not changing. And then all of this comes down here. And then and then this actually, and then the difference is this should be minus, and this should be minus. So it reverses the direction. And then after that, you can copy this line, paste it down here. So the difference between these two loops is this one is going sort of in the positive version of both directions, and this one's going in the negative. And obviously when one of the directions is 0, positive and negative are the same. So now we've checked in bounds. We've got this check line function that we're not actually using anywhere. And the way I will test this is I will make a quick copy of the check row name, rename the old one to old, and then see if I can implement check row by just calling check line, check line, row, call, and then what values for row direction and column direction. Well, row is going nowhere, so it's 0, and column is going first to the right, positive, and then to the left, negative. And so in theory, this little one-line function should be the same as this one at is replacing. So if I save that, and if I haven't done, I'm going to open up the console because chance that I broke something, not zero. And in fact, I did break something. What's going on? Click to start. Okay, so we have a bug. I did a bunch of stuff all at once, and it didn't work the way I expected. But I still know, like, oh, and you know what the bug is? I need to return the value that this function returns. So that's because if I don't say return, this will just return undefined. Undefined is equivalent to false, and so therefore check row is effectively always returning false. So let's see if that does the trick. I should get a win. Okay, good. So yes, that was indeed it. And so again, debugging is a lot easier when you check frequently. So I know what I had just done. If I didn't notice that return, then I could have come up here. I might have put a console log to see that check line was being called, though obviously it was. I could have printed out the count down here and seen what it was, that it was greater than 4, and then I might have come up here and added a print what check row returned, and then I would have seen undefined, and I would have realized my problem if I hadn't already. Okay, so now, so we can delete this whole check row old, and we can do the same trick with check column, except we don't, so we don't need all this because we're gonna write return check line row call where we start. This time the column is going nowhere, but the row starts out going down, i.e. 1, column is 0, and let's see if that works. So we're going to play in a column, and we found a win. Just for grins, let's make sure it works the other way, where the column, like the last move, is at the top of the column. Great. So that looks, and we'll just for further grins, we will check that it works in the middle. Also works. Great. So we've got a column that's working, and now let's delete that, and const, I'm going to go a little bit faster here. Check diagonal 1, row call, oops, return check line row call, and check diagonal 1 starts out going row minus I, so that's -1, and column plus I, so that's +1. And then obviously the check line takes care of this switching things for us. And now check diagonal 2, and change this one to old. It goes positive, positive, and then negative, negative. So that is positive, positive, and then flips to negative, negative. And so that should also, I think, work. Whoops. Missing an initializer at line 90. What did I do here? Oh, whoops. Left out an equal sign. There we go. Should have paid attention to those red squigglies. Okay, so now diagonal down. We'll even do a middle tested one. And it found the win. And found the win there. Okay, and so that means we can delete these two. And now we've got our check line is still, 20 lines long or whatever, 30 even. And we added this in bounds. And isWinner is basically 5 body lines, and that these are actually all just one line each, so much so that I could like copy these up here and look at them. I might even just get rid of those altogether and just say check line row column 0, 1, check line row column 1, 0, check line row column -1, 1, and check line 1, 1. And now I can get rid of these. And then as the very last step of this adventure, I've noticed that the two loops in this loop and this loop are also quite similar, right? If we mark, again, the lines that are different, this line is different because this is negative and that's positive, but otherwise it's the same. This line is different because this is positive and this is negative, but otherwise it's the same. And then the rest, because we've gotten the two values into variables, the inbounds check is the same, that check is the same, the count, everything is the same. So now I want to think about can I break this out into a function that captures what that is actually doing? And so this is checking a line. So let's call this new function check in direction. Sorry, in direction. It's going to still need the row and the column. I'm going to call this variable sign for reasons that will become apparent in a sec. So I copy this, and remember we said the only difference between this line and this line was positive versus negative, and this line is positive versus negative. And so oops, call 2Ls. So what I need to do there is add one more multiplication. If I multiply by the sign, if the sign is 1, this is just like adding, but if the sign is -1, this will be the same as subtracting. And so basically so what this is going to look like is I'm going to say check in direction row call row direction call direction 1, meaning positive. And that replaces all of this. However, one problem, which is this function is changing the variable count. Well, the variable count doesn't exist in this function, so that's easy enough to fix. And I'm going to set this to 0 this time, for reasons we'll see in a sec. And actually, I'm going to change the name of this to count. Actually, let's do it with rename symbol. Count in direction. So this is a basic counting loop like we learned about last semester. So it starts at 0, we loop 3 times, and we're going to get a count. So some count between 0 and 3. And so now we're going to increment our count variable by that, right? Because this code could directly modify the count variable, but this function can't. And in case you're wondering, we can't pass count in and have it, like it doesn't, like if it, as soon as we pass it in, it becomes its own variable that only exists inside this function. So, but this should work. And since this check line is now used everywhere, if that broke, it broke everything. So let's do a quick check. But the row checking still works, so that suggests we're on the right track. And now the whole point is we can just copy this and change the sign argument to -1, and that handles this whole case. And so now we have initialize our count to 1 for the current piece. And then we look in one direction, which might be to the right, and then the other to the left, or this might be up and down, or one direction on the diagonal, and so forth. And so now this function is still very slightly complicated because it's doing all this bounds checking and breaking, but it's just basically a counting loop, right? One for loop, makes some extra variables, checks that they're in bounds, checks the value, returns, blah, blah, blah. And now, in fact, we can further simplify this. I'll leave it like that. We could also, I was thinking we could also just return here, right? Which is a little more, we're used to that rather than break, but I think the break is fine here. It has the advantage that we know this always returns, right? So this is just like initialize a count, possibly increment it, and then return it. Okay, so now, if you recall at the beginning, winners went from line 41 to like 100 and something. And so now we have 1, 2, 3, 4 functions instead of just one, but they're quite a bit shorter. And some of the, this one is just sort of one slightly complicated line. This one's 5 lines. This is the most complicated. And we can kind of see the logic, assuming we understand what check line does, right? This is checking in one direction and another, and there's the 4 directions. So hopefully that's more clear. It's, if you were coming to this code for the first time, you could look at this function and see roughly what it's doing. And you don't know until you read further down exactly what check line does, but the name suggests something. And then and row and column, like you can see where this was called. It was called with the row and column where we played. And so, okay, we're starting from where we played and we're looking, and then you just have to see what these arguments mean. And, oh, row direction, column direction, that makes sense. And then further read on and see how this works. So that, I believe, completes our tuning up of that isWinner function, detects the wins in all kinds of different ways. We'll go over here. Other things that this game might want to do is like stop playing after someone wins. Obviously, if it's going to be Connect 4, it needs to find the bottom row when we play rather than just putting it wherever we clicked. But that's adventure for another day. Okay, so if this was your code, then obviously I've given you a bunch of hints about how to clean this up. And if you are also working on Connect 4, you could obviously do something like this. There are other ways, and I may make another video to show a different way to get there, starting from a different place. But that's enough for now, I think, on this one. All right, take it easy.